Okay, we're about to start into a module on learning to program computers. We're going to use a program language called Python. There's a number of good benefits. It's a good learning programming language. It's still used widely around the world for professional purposes, and there's lots and lots of people using it for research. We'll talk about a few of those a bit later as we go through. Python itself was actually created around 1991. It was actually released publicly by a guy called Guido van Rossum. He was a Dutch engineer and mathematician working for the Dutch Centre of Mathematics and Engineering, very prestigious institute. And what he'd found was most of the programming languages he was used to working with at the time there was Pascal and C, quite heavily used. He found that they were not helping him produce very good code quickly, and they weren't allowing him to focus upon the mathematical problems and the engineering problems he was trying to solve. He was spending more time trying to work out how to get the program to work. So he developed Python with the idea that he would help people read the code quickly so that they can work on their problems, because you spend more time reading code than you do writing it. The name Python actually comes from a comedy troupe in the UK called Monty Python's Flying Circus. They were around in the very late 1960s, and why he chose it, I'm not too sure. The key features that we are focused on and why we would like to use it is there's some code snippets here. These two programs do exactly the same thing. On the left we've got Python, and on the right we've got JavaScript. And initially you might look at them and go, it doesn't seem to be that much. But when you look at each individual line, and they do more or less say the same things line by line, the top line says here's a list of names, and that's quite straightforward. And it's not too bad in JavaScript, although you've got to use this command var, and you've got an extra semicolon on the end of the command. A lot of languages have that idea that they need a special marker to say this is the end of a command. Python doesn't need that. Then we've got in here that we want to go through for every name in the list of names, so that's quite readable. It says I want to take each name from this list one at a time, so it will get Matthew, Mark, Luke, John. So for every name in that list, the JavaScript version, you have to use an another variable, and this variable doesn't really mean anything in the real context. It just says which number of the names am I in, and then it says have I gone past the end of the list. If not, we increment the counter, and all of this is about dealing with a counter called I, and it's not focused on the job. It's not focused upon we're dealing with a list of names. And then finally, there is a funny thing here with the colon. We'll talk about that when we come to it, but the colon says here's a list of things to do, just like English. And what the first one is it prints out somebody's name. This is the JavaScript version. This is because JavaScript has to run inside a console, but the name there isn't too bad, apart from you've got to use this funny form so that you can get one name out of the list. So the logical thing about this, and the nice thing about Python, is the aim of it is for the code to be a lot more readable. You should quickly be able to read the code and decide, do I need to deal with this bit or not? Logical blocks of code in many languages have this funny brace idea as well, these brackets around groups of code to group them. Python uses indentation, and that is the hardest thing most people have to deal with when they first join the Python programming community, is getting used to, I must line bits of code up properly so that Python knows this is part of the same group of commands. So Python is pretty much friendly to programming any way you would like. There are lots of different styles of programming. Object orientation or functional programming are one. Modular programming is breaking things down in a slightly different way, but breaking apart the problem. Python supports all of them, pretty much. You might have, they may not support them as nicely as a dedicated language for that language, but you can do those sorts of programming. What's really beautiful about Python is this whole thing about having lists of things. You can see from this code here that the list was a lot easier to deal with in the for loop there than it was in JavaScript. And that's because that was one of the first things he decided he had to do. He had to make lists natural to Python, rather than appearing to be something you have to create and work with hard, in a hard way. He wanted to make it as natural as possible. And what's good for mathematicians and engineers is Python nowadays supports something called complex numbers, which allows a lot of maths, physics and engineering calculations to be done quite well and efficiently. If you have to deal with complex numbers in other languages, you have to use very special ways of working. But this is naturally built into Python. Right. Python has some good efficiencies, and it also has some problems about efficiency. Python is not very fast. It's not what's called a compiled language. It's an interpreted language. So every time Python comes along a command, it has to try and work out how to make that command work. There is a little bit of a step below that though. Python does actually create something called bytecode, where there's a shortened version of the command, so a lot of those decisions have already been made. But the bytecode itself still needs Python to run, and it still needs to be interpreted and call the right bits of code within Python. But interpreted languages generally have a useful stat that they can be executed quite quickly. This gives Python a nice feature that it has what's called a shell, a command, or a terminal. And this allows you to actually try experiments with the language. And this is something you really must learn, is you've got to learn to play when you learn a new command. Python programming, you've got to take commands, look at them, and to work out what they do, you've got to change those commands and say, well, what if I tried this? What if I tried that? Computer science is a true science. And it's even better than most of the sciences you get to do for scientific methods, than the other sciences in school. Because we will very rarely tell you, no, don't do that. You're unlikely to cause any damage. The worst we'll have to do is say, oh, close off your Python and restart it. There are some simple errors that can cause Python to just not work properly. But you're not going to do any permanent damage, so we don't have to worry about you putting the wrong thing together and it permanently causing a damage or causing a problem. Other places you will be told, oh no, yes, you really shouldn't swing a 2-ton weight at that person. It might hurt them. You shouldn't mix those two chemicals. We really won't tell that to you when you're learning to program. There's not much you can do that will cause a problem. We're back to this. There's a rich set of libraries. We'll talk about the libraries in a minute, but libraries are just pre-written programs that you can use with yours. They don't in themselves normally do an end-to-end program, but they contain ways of doing things. Like if you want to draw a mug on the screen, someone might have written a program to draw a mug on the screen, or at least draw these points on the screen, and somebody else gives you a set of data that goes together with it to create the mug on the screen. So there are lots and lots of programs around. It's a very popular language. Most of the big tech companies use Python in some way. The early rounds of Google's AI system were written using Python because it was a fast development system. Python is supported on many platforms. Unfortunately for people with Chromebooks, it's not supported properly at all, unless you can get a Linux distribution or a Linux environment running within there, then you can use Python. Supported by Mac OS, particularly on MacBooks. Not so much on iPads. You need to, iPads are a bit restricted, same as the Chromebooks, that's a problem. Windows, fully supported. Can even run them on small single board computers like a Raspberry Pi. But because of the amount of memory it takes up to store the Python code, or the Python engine itself, it won't run on something like an Arduino. It's too small. But there are small development boards of that size now. I've got a couple of ESP32s, which this is. They're small single board computers, look pretty much like an Arduino, but you can run a version of Python on there. It's not quite full, but you can do displays on the screen, like this one, on a built-in screen. Really impressed when I got that working. Next section is Python. What is it used for? There's loads of libraries, people all over the world needing to do programming as part of their job. We've got loads of different services for it. People use it for maintaining databases, running web servers, heavily by mathematicians. We used to have to use something called MATLAB, but a lot of researchers now seem to quite like programming in Python for it. Data analysis and visualization, drawing graphs. It's useful for in most Windows environments. So Mac OS and Windows, you can actually write proper programs in them. Any form of voice recognition or these artificial intelligence things, there are libraries out there to do it. So all over the world, lots of people are using Python. Okay, so the size, we need a modern computer environment, so Arduino won't work because the interpreter needs space and memory. The speed, because instruction is interpreted, the code runs slower than compiled programs. Compiled programs generally talk very close to the processor language directly, normally through an operating system, but they do contain proper code that says go and do this, and the CPU does it immediately. Interpreted programs, they get an instruction, they say, well, I need to be able to do this, 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 and this, and then it gives a list of things to the processor to do, which slows up the rate at which the program can run. That's why you won't find things like games like World of Warcraft or anything built solely in Python. But Python might be used to help them develop the characters, develop the character images, or even build behaviors. Things that don't need complete real-time rendering and generation may use code that was written in Python and then compiled into a language like C. The intermediate Python code is useful. It helps us actually work the program. So this is why we are using Python for programming. One of the parts I haven't mentioned about efficiency and speed. If you write compiled code in C, it takes a long time to compile that program, to test it and move forwards. So if you're not building a program that really needs high-speed processor work, you can get away with actually having a faster development time with things like Python, because you can write your code quite quickly check it, checked it worked, debug it, fix any problems, and then move fairly quickly through your problem. That was why Guido created it. Okay, so it was created for him so he could focus on solving real problems he needed to solve with a computer, not spend all his time programming. Okay, this is your task for this week, and for homework is to write an advert to emphasize the benefits of Python. Remember, we want benefits, not limitations. It needs to be a sheet of A4 or a 25-second video will do. Please try and make it entertaining. try and get people's attention. Don't just put lots and lots of facts all over a sheet. People probably won't read it. Think about pleasing to the eye and enticing people to come along. Okay, that's your work. Off you go.